to low. And so let's just think about what we saw with the battery flow. Okay, so we're flowing from that high negative area and is going into the positive where we have less electrons. Okay, one way that we describe circuits, we look at a water system with the water pump. Okay, so voltage would be that water pressure. Okay, that gives what thing that gives off the water pressure that causes the water to flow. Okay, in this case, voltage in the circuit is the electrical pressure that pushes and pulls the charge. Okay, and we measure voltage in volts. And then next week, when we go into the different types of circuits, we will explain more as to what potential difference is. But just know when we look at the water, voltage is voltage is the thing that gives that water pressure to flow through. Okay. Um, with voltage and current, when we have a wire connected to the ends of the battery or generator, whatever is giving off that electricity, then the voltage will push or pull those electrons through a conductor. Remember, conductor, the best conductors are metal, and the wire is a conductor. Okay. All right, resistance. Okay, so if we go back to the water analogy, okay, you see that we have the same size tank, but we have different hoses. Okay, so which one will have less water flowing through? It would be the one on the right because it has more resistance. It is a smaller path for the electrons to flow through. But if you look at the left, we will supply more water will flow because it has less resistance. Okay, so resistance is defined as the tendency for a material to oppose the flow of electrons. Okay, we when we draw our circuits in the symbols from earlier, you see a resistor with the little zigzag lines. Just know that your light bulb is also a resistor. Anything that is using that electrical energy is also a resistor because it's taking that flow of electrons. Okay, we measure resistance in ohms. So you may see the word ohms as a unit, or you'll see this horseshoe shaped symbol, which is the Greek letter omega. So you will see either or as a unit when we look at resistance. Okay. Ohm's law talks about the relationship between the voltage of the circuit, the amount of current flowing through, and then the resistance that we have attached to the circuit. Okay? So voltage is directly proportional to current and resistance. That means whatever change I make to current, you're going to see that same change to voltage. And that's if I keep the R the same. If I change the resistance, then I will change the voltage in the same way and keep I the same. Now, if I change I and if I change the R, I will multiply that change. So if I double the I, then that's going to be a 2. And if I triple the R, then that's a 3. What's 2 times 3? 6. So my voltage is going to have is going to be 6 times greater than before. Now, V is voltage, R is resistor. Okay, so that's pretty easy to organize those letters. But I represents current. Okay, and current and resistance are inversely related, meaning if my current increases, resistance is the opposite change, is going to decrease. If I increase the resistance, then I'm going to have less flow.